Compound interest, part 3, promissory notes. No new information here. So this is completely technique. So let's just kind of understand that we have two types of promissory notes, non-interest bearing and interest bearing. Okay, so two types. Promissory notes you see a lot in the real world. So it's somewhat of an important concept because in finance they pop up a lot, and if you ever look at the corporate financing, you see promissory notes appear there quite a lot. So it's kind of an important topic for us. We're going to start by just talking about how each one of these are structured. So I'll go through an example, and we'll just look at the points and see how it's structured, and then we'll do a couple of examples at the very end. Okay. So non-interest bearing promissory notes. Okay, so just the terminology, or just sort of the way it looks, is the face value of the interest-bearing note is also its maturity value. Okay, so that's important. Okay, the proceeds of the note are the present value of its face value at the date of the discount. Okay, so when you look at the diagram there and you look at the timeline there, you see, okay, the face value, that's essentially what you're going to receive at the end of the note. Okay, and then you discount it back to when you're actually buying it. You know, so we're assuming that you're buying this not at the issue date, okay, but you're buying it some period after, but before the maturity date. So this is sort of a little bit of I don't know, when you have in the movie, you're sort of looking ahead into bonds, which we will do at the very end. Okay, so the key is the face value is the maturity value, the amount you will receive at the end. We discount that amount back to the date that we are buying this particular promissory note. So, for instance, we're going to find the proceeds of a non-interest bearing. So remember, two types of promissory notes, non-interest bearing, interest bearing. Okay. We're going to find the proceeds, that's how much money you get, or how much money you pay, depending on which side of the transaction you are on, of a non-interest bearing note for $5,000 discounted 2 years before maturity. Interest rate is 3% compounded monthly. Okay, so in 2 years we'll receive the $5,000. Right? So so we find the I, normal, like we did before. We find the N, just like we did before. Okay, so none of that is different. We find the present value, discounted back 2 years, because we're going to get that $5,000 in the future. Going to get the $5,000 in the future. So we discount it back to see what we would either pay to buy this particular instrument, or if we were issuing the promissory note. So if we were a corporate issuer of this promissory note, then when we sold this $5,000 promise to pay in 2 years, we would get $4,709.18 today. Okay, so very straightforward with the non-interest bearing promissory notes, very similar to what we've discussed before. Okay, things get a little bit different with the interest bearing notes. Okay, so the interest bearing notes are the slightly trickier one. Okay. There's a two-step procedure to solving this. So there is a procedure. You follow the procedure, everything is okay, right? And it's not complicated, but we just have to understand that it's extremely important whether the promissory note is interest bearing or non-interest bearing. That is extremely important. So the proceeds, okay, money you get, of an interest bearing note are equal to the present value of the maturity value of the note at the date of the discount. Okay. 2 steps required for this. First of all, we don't know what the maturity value of the note is. So for the non-interest bearing account, promissory note, we knew we would receive a certain amount at maturity. In this case, we do not know what we're going to receive at maturity. So we have to now find a future value. Okay. So we have to find the maturity value of the note, step 1. Then we determine the proceeds by discounting that maturity value. Okay? So in essence, in big picture, they're both the same, right? Really, we need a maturity value. We discount the maturity value back to the discount date. We do that for both. However, for the non-interest bearing promissory note, the maturity value is already provided for us. It's part of the specification of the promissory note, whereas for the interest bearing promissory note, we're not given it. We have to determine it, and then we discount it back, okay? So they bear some similarities and maybe just slight differences as well. Okay, so when we look at what's happening here, we see that in this example, on April 1st, 2014, a 3-year promissory note for $5,000 is issued with an interest rate of 6% compounded semi-annually. The note is discounted on April 1st, 2016 at 8% quarterly. Find the proceeds of the note. So we kind of see that this is a little more complicated because there's a couple of interest rates floating around in there. And that can be a little bit on the confusing side. But we follow our 2-step procedure. We first find the maturity value. Now the maturity value we find using the interest rate specified in the promissory note. In this case, that's the 6% compounded annually. When we go to do step 2 and discount it back to the date of purchase, then we use the second interest rate, which is the 8% compounded quarterly. Okay. And this is a real life financial instrument, big league stuff here. Okay. So step 1, maturity value, right? And we have all that calculation, and we find the future value because maturity value is a future value. Right, and we have the $5,000. Periodic interest rate is 0.03. It's 6 periods because it's 6 periods into the future, and we get $5,970 and a whole bunch of cents. Okay, so that's how much we will receive in the future. That is our maturity value. Step 1, check it off. It's done. Now we have to discount that back to the date of purchase or the date of sale, depending on your perspective. And we discount that back at the second interest rate, which was 8% compounded quarterly. Okay, and that's 0.02 per every 3 months or per quarter. So that's our periodic rate, and we just find the present value of that $5,970 and some cents as of the date of sale, and we get the present value of $515.60. Okay, so with the interest-bearing note, we get to use both future value and present value, which makes it awesome, real-life tool, big league finance stuff, very realistic, and from the old teaching perspective, we get to use both present values and future values in the same question. And integration is always excites an instructor and any finance kind of person, because we get to bring a whole bunch of stuff together and sort of see what happens, and it's an exciting challenge. Okay, let's do some examples. Okay, practice. Gotta love practice. Question number 1, we're going to find the proceeds of a $1,000 4-year note bearing interest. Aha, interest bearing. All right, so that sends off some bells in our head. Okay. We know there's going to be a 2-step procedure. Okay. So now, let's do this. Draw a timeline, just so I can kind of just get a sense for what's going on here. So at the beginning, we have $1,000, 4-year note. So out here in 4 years is the maturity. Okay. So step 1 is we need to find the future value. Okay, so I'm just going to call that circle with a 1. Step 1. We're going to find the future value. It's got 2% on it. And then step 2 is we're going to go back, discounted that back 2.5 years at 3%. Okay, and that is our step 2. So 2-step procedure, we've got that all sketched out. Okay. So step 1 for us, let's find that maturity value or that future value. So once we know what we're doing, we just follow it along, right? Future value, present value. This is just plug and play formula time here. Okay, we started off with the $1,000. 1 plus the 2% interest, and that one was compounded quarterly, so divide by 4. How many quarters in 4 years? 4 times 4 is 16 quarters. And we get the future value of 1,083.071151. Okay. So now we're going to go on to step 2. Because remember, this is an interest-bearing promissory note. And so now we find the present value on the date of sale or on the date of offering. Okay. And so we take that maturity value, $1,083 and a few cents, and lots of decimal spots. And then we use the second interest rate, okay, because it's a discounted, so discounted at 3% compounded monthly. So we've done that before. That's not new. How many months are we discounting this back? 2.5 years, and that is 30 months. Okay, you can verify that. Probably a good idea to do that just so that you figure it out as well. Okay. And then after that, it's just the present value, and it gives us the proceeds, $1,004, and let's call it 91 cents. And I'll just round it out. Although sometimes when they actually do these calculations, they may keep them to many decimal spots because you may sell many notes as part of an offering. Depends. Okay, so we've got that one settled out. Let's go on to question number 2. Question number 2 is 7-year non-interest bearing account for $10,000. So we now know, because it's non-interest bearing, that the $10,000 is what we will receive in the future. Okay, so question number 2, so now we know that the future value is this $10,000, and what we want is to find the present value of that amount. Okay, so now it's become a little easier. We get to skip a step. So we find the present value of that $10,000. 1 plus, what was our interest rate here? Looks like 4% compounded quarterly. 0.04%. Oh, okay. Lots of 4s in there. Compounded quarterly. So now we're counting quarters again. 3 years has 3 times 4, 12 quarters in it. How many quarters in 8 months? 3 months a quarter. So I have 2 quarters and 2/3. Right? So I have, and this is present value, it's a negative 14.666667 quarters. Okay, verify that. Get that in your head, because you'll be the ones that have to calculate this on an exam and in a pressure situation. So you want to make sure you've got that settled out in your own head and in a calculation mode that works for you. Okay. Then ultimately the present value is just 86.4211. Okay. But we're counting quarters. The tricky part comes when we have a partial quarter, but it's not impossible. Okay. Alternatively, if you like, another way to do it is to count this all up in months and divide by 3. That's can be a useful way that some students have found pretty easy to work with. You have 3 years, that's 36 months, plus 8 months, that's 44 months, divided by 3, and you get to the same spot as we just did. So you may find that an easy way to look at this type of problem as well. Okay. Last, but no means least, this is the most exciting one, is quarter number 3. Quarter number 3. Question number 3. Okay. So we have a $2,800 promissory note issued without interest. Okay, so it's similar to what we just dealt with in question number 2. For 5 years, on a particular date. Oh, we're going to get to do something we haven't done since Unit 5. It's very exciting. Is discounted on June the 30th, 2020. Okay, once you start hearing specific dates thrown around, the days between dates function on your calculator is gonna be big. See unit number 5. Skip ahead. Look at what we were doing way back in Unit 5 with simple interest when we were finding days between dates. Same kind of idea. Go give that a quick look. Okay, so we want to find the compound discount. That's interesting. We saw that on the slide. And compound discount is just another way for saying, hey, how much interest are you going to pay on this thing? Okay, and that's just the difference between future value minus the present value. Okay, and again, like we commented before when we did this, the regulators often expect you to provide that, especially if it's a consumer loan. Okay, let's kind of do a timeline, just to sketch things out for us. So what happens? That's great speaking, right? 5 years on is issued on January 13, 2016, discounted on June the 30th at 6% compounded quarterly. Okay, so what that means is that on January the 13th, 2021, 5 years from the issue date. Okay, so when you're looking back at this and you look and say, how come he's taking out 2021 and it says 2016 in the question, where did the 2021 come from? You'll note that 5 years from January the 13th, 2016, which is when the promissory note matures, is in 2021. Okay, so on that date, we get the $2,800. Then we discount that back to June the 30th, 2020. Okay. Key thing to note now. How many days between June the 30th, 2020 and January the 13th, 2021? And that is when you want to go and test out your days between dates abilities on your calculator. I'll skip ahead to that just so that you can verify the days between dates. In this case, 197 days. Go double check. Again, it's not so important that I can do it. It's extremely important that you can do it. Okay, so we have 197 days. So in this particular case, we need to do this in quarters, right? So I need M. And I need N, but I need N especially, is I need to know the number of quarters, right? Because we're counting quarters. And so I see that this is a little bit of a tricky one to work with. So I'm going to go in fractions of a year, 197 divided by 365, and then multiply that by 4 to get 2.1589. Okay, so all I did here is I found the fraction of a year, which is this is like finding the number of years, and I multiplied it by 4 because there's 4 quarters in a year. Just happens that this was a fraction of a year, but that's okay. That's okay. That just, whether it's a 1, whether it's a 2, whether it's a point something. Doesn't matter. It's still the number of years. It can be less than a year. It could be 3/4 of a year, half a year, a quarter of a year, and so on. Multiplied by the number of quarters per year, and I get the number of quarters in total. Okay. So after that, so you can kind of see this question's got a lot of good stuff in it. I'm going to find the present value of that $2,800 because, of course, it is, without interest. So the maturity value is the $2,800. So we already know the future value. And then 1 plus 0.06 divided by 4 because that's quarterly. And then negative exponent because this is the present value, 2.1589 because that's the number of quarters. We get a present value at the end of all this of $2,711.43. We want the compound discount. And so we look at our future value, which we know to be the $2,800, subtract from it the proceeds or the present value. And through that whole process, we get $88.57. Okay. And that wraps up that particular set of problem-solving questions. So a lot of integration of things that we've seen in various parts of the class, all nicely coming together in this selection of questions. Okay. Any questions, of course, you can always drop me an email.